Okay. We got to go. Good morning. Before I start, I want to apologize to that front kind of corner. If I disappear behind the pillar, it's not my fault. So if you want to see me most of the time, then you can move to this side of the room where you're not hiding behind the big concrete pillar. But other than that, good morning. I hope we're all feeling as fresh this morning as I am. I was not out late last night looking at all the San Francisco bars and trying out the beer. I was in my hotel room being good and diligent so that I'm fresh for this morning. Who else is fresh for this morning? Excellent. Look at that. All right, so we're going to talk about Azure's NoSQL database as a service called Azure DocumentDB. My name's Ryan. I'm one of the program managers on the team. In case you haven't seen me or heard me before. Who saw my embarrassing GA dance on video that's gone viral and spread everywhere? Good. Not many people. I have some dignity left. That's awesome. Okay. So let's kind of take a look. Please remember at the end of the session, there will be a slide with a QR code. Please submit an eval. And that's it. All right. So what are we going to do today? I had a couple of ideas. I thought, depending on how many people were pub crawling last night, we could go and have some coffee, but most people seem to be fresh. So what we're going to do today is we're going to have a look at document databases, just quickly, briefly. As a show of hands, who's never used a document database before? A lot of people. All right, great. So we're going to do a quick recap of document databases, what they're good for, what they're not so good for, kind of a vague difference between them and relational databases. Who has used some other document database? So like a Mongo or a Raven, CouchDB. Mongo, the big favorite? Okay. Anyone a DynamoDB user? Okay, a couple DynamoDBs. Well, just to give an idea of what you guys have been doing. Then we're going to kind of do a quick intro recap to DocumentDB. It's not going to be a, we're not going to spend too much time on that. We want to try to get down to the building the apps part and the tips and tricks for building apps, because that's where I really want to spend a lot of time. And then we're going to take a quick look at the road ahead. We've got some feedback from people that say, we really want to know what you guys are doing, what's on your road ahead. And we're not really usually very good at sharing that kind of info publicly because it commits us to stuff, but that's okay. I'll share what's on our road ahead. So what is a document database? A document database is a type of database that is very good at dealing with JSON data. So documents that look like that. Don't worry if you can't read it, you don't really need to. As long as you get the idea that it's a hierarchical kind of JSON document, it's got some nesting in it, it can have arrays in it, it can have subdocuments in it. The idea is that that thing is a self-contained entity that describes some entity that you're working with, right? Whether it be a customer with orders and order lines and products, or a contact with addresses and contact details, or anything that's kind of like self-contained into a document. And that's, I think, where the name kind of comes from. And if I had a time machine, I'd go back in time and try and influence whoever called a document database, I'd try and get them to call it something else, because it kind of creates a little bit of confusion. But when you think about these document databases, they really are these self-contained documents. Okay? When you deal with a relational database like SQL Server, you're dealing with tables, you're dealing with records, and those records relate to other records. And to get the entity, what you actually got to go do is you got to go and join a whole bunch of tables together and compose the entity on the fly. Okay. Document databases take a different approach. They say, hey, instead of me doing this computation and calculation and these joins on the fly, what you should do is model your documents as these kind of complete entities. Okay. And there's a very good reason why there are some papers and studies that say document databases scale at internet scale. They perform a whole lot better than relational databases do. Okay? And this is one of the very big reasons. Relational databases have to do a lot of work on the fly when you start joining 15 tables together to compose an entity. And every time you write an entity, it has to go and kind of break that up and write it to 15 different tables and maintain locks and all that kind of stuff while it's busy doing that, right? Whereas a document database, you're working on that single document entity. So we don't need to lock anything else. All we do is we persist just that one entity the whole time, all right? So there's a fundamental difference between those two. So when you start working with document databases, think about that, all right? So they really are good to this kind of document. They're not so well suited to that kind of document, okay? Now, that's also a JSON document, and I could put that into a document database. No problem at all, okay? It'll work. And I could go and search or query for things by ID or by text, okay? This kind of document, though, is probably better served out of something like Azure Search or Elasticsearch or Solar or one of these search engines. Why? Because most of the searching that you're going to do on this document is within that big block of text, okay? You're going to be wanting to do full text indexing or full text searching, fuzzy logic searching, pattern matching, soundex matching, all of that kind of stuff. And that's probably better suited to a search engine rather than a database engine, okay? So something like this, probably better suited in Azure Search than in a document database, okay? It'll work. Sure, you can do it. Nothing's going to stop you, but there are other options. And lastly, they're definitely not for this kind of document, okay? And I've had a lot of people come to me and say, this is awesome. How do I store my Word documents in Azure Document Database? Document databases are not for this kind of document, all right? They really are for JSON documents, not Word documents or Excel documents. Now, if you wanted to build a CMS or a content management solution that took Word documents and you wanted to build it in something like Azure DocumentDB, you probably could, right? Because what you would do is you would create a metadata document, and in that JSON, you would put all the searchable, queryable fields that you want to query on. You'd put that in the JSON, and then using DocumentDB's attachment property, you would attach the Word document, the binary, to the metadata and persist that in DocumentDB. Okay? Because what we then do is we take that binary, we put it into blob storage, and now we only keep and index the small metadata file. Okay? So we don't try and index these things. If you want to do indexing and searching inside of your Word documents and Office documents, SharePoint's a much better option for you. Okay? It's designed to do that sort of thing. Seems my clicker has a very limited range. All right, so one of the things that have made document databases by far the most popular database at the moment, if you look at stats on the quickest growing databases, there is one whose name shall not be mentioned in the room, that is probably the third or fourth most popular database in terms of growing this in the last couple of years. And there's a very, very good reason why developers are flocking to document databases, okay? And that's because they love document databases and document databases love developers, okay? Mostly document database, if you were in our session yesterday on the data, who was in the session yesterday on data foundations? Nobody? Okay. So you would have seen me there yesterday how developer-friendly a document database is. On stage, on the fly, I was asked to make a change to an application, and without going through a whole modeling exercise and without going through a whole ORM mapping exercise, all I did was open up Visual Studio, make a change to a model class, make a change to the UI, and I could then persist the new field in the database, right? And that's how easy it is. You can, and it's so good for the way we build applications today, okay? Who remembers, I'm just doing a quick scan of the audience, but who remembers when we built systems where we would kind of take a 6-month planning phase and we would sit down and we would do this whole complicated, data modeling exercise. And then after that 6-month kind of period, we'd then go into planning and we'd figure out how to map that into our domain objects. And eventually about a year later, we would actually start building an application, right? We don't build applications like that anymore. We sit down and we go, right, I got a great idea. We open up an IDE, whatever that is, and we start coding, and now we just want to persist that and retrieve it from the database. That's how we work. And when we want to make a change, we go back into the application and we make that code change. We don't have to go through that whole process of kind of taking servers offline, updating or applying update scripts to change the schema, et cetera, et cetera. We don't have to create these crazy schemas to deal with the fact that not all records have this property. You just go in and you work with them. what we really like about document databases as well is this notion of low impedance, okay? Who loves sitting down and mapping your programming language type, your .NET type, into a database type? Who loves that? Who loves saying that this domain object, right, is actually this field in that database table, and this domain property is that field in that table, and change its type and do this horrible mapping thing? Who loves doing that? Many people, okay? Well, with these things, you don't actually have to do that. Most of the time, your views and your view models, if you're working in Ajax and Knockup, or you know, all of those kinds of tools, you're probably already working with a JSON file of some form, right? You're working in JavaScript, you're working with a JSON file already. Well, now you've got this JSON object. Wouldn't it be cool if I could just take that JSON object and persist it, and get the JSON object back and bind it to my view, okay? And that's exactly what document databases allow you to do, right? So it just works. That's how, yeah, most of the time it should just work, all right? And it's fast. It's fast to get going, it's fast to use them, it's fast to develop against them. And for most part, they perform really, really well if you've done, you know, some due diligence, okay? And just because they're kind of really quick and really easy to get up and running, a lot of people, you know, start off in a particular way, and without giving any thought to how they should model their data, okay, or how they should design their entities, they get stuck. They get stuck, okay, and they find that, you know, 6 months in, their data model isn't working for them anymore, okay, because their app's grown too big, or their documents have grown too big, or their queries are slowing down, or whatever the case may be. So you'll still have those kinds of issues, but it really is much, much quicker to go in, refactor your data model, and kind of keep going, all right? So Azure DocumentDB, a fully managed, highly scalable, NoSQL document database as a service, all right? Yes, it is only available in Azure today, and that's where we are. When we started out with this, it's been a long road for us. We've been working on this probably 2 years, around about 2 years. When we first started out when various people within, or various groups within Microsoft came to the data group, right? Because we're part of the same group that builds SQL Server, believe it or not. We're also part of the same group that builds Azure Search and all the other cool data lake and, you know, all those kind of other cool Azure data services. We're part of the same group. And they came to that group and they said, hey guys, we really want to use a document database. Which is the document database you recommend for us? And then we kind of started looking around, and, you know, this one worked some cases, that one worked some cases, but largely we weren't happy as a data group with any of the databases that were out there. So we actually wanted to take a step back and say, can we do some things better, right? And these have become our four kind of pillars that we want to believe on, all right? The fact that we really want to be able to enable query over schema-free JSON, right? Now, schema-free is a bit of a buzzword, right? Because your document actually has some kind of a schema, because as soon as you structure a document in a particular way, it infers a schema, right? So we're not really schema-free, we're schema-flexible, because we allow you to change that structure really easily, but it has some kind of a schema, right? But what we really want to be able to do is not just allow you to persist these documents in whatever format or whatever schema you like, but we want you very quickly and very easily to be able to query them. And that's where we found a lot of these databases break down, okay? A lot of them allow you to quickly and easily store your JSON documents, but then in order to be able to go and efficiently query them, you have to go define indexes, okay? Now, as soon as you define an index, you've defined a schema, right? Because as soon as your document changes, if it doesn't match what your schema says, you're not going to be able to query for it, right? As soon as you start working and you start kind of evolving your data models, you now have to go and kind of rebuild indexes, and you have to wait for them to rebuild and all of that kind of stuff. We wanted to be able to take a JSON document with any arbitrary kind of properties, any level of nesting, any arbitrary property in that document, persist it in the database, and immediately be able to query using an index on any property in that document, okay? And when we started out, none of the databases on the market, and I don't believe any on the market today, still offer that, right? So that was one of the very first things that we set out to do. And we set out with, we went to the Microsoft research guys, and we said to them, hey, help us, because we don't know how to do this. It must be possible. Anything's possible given enough time and money. We don't know how to do this. Can you help? And the Microsoft research guys were amazing. They worked with our engineers, and they built a new type of index. Okay. So a lot of databases, if you've done any database work, a lot of databases share some common index engines, right? We don't. We have a new index engine that runs Azure DocumentDB. Now, a lot of people have been asking about details of that index engine, and we have a white paper that will be published shortly. And Dharma, our principal engineer, he will be presenting at a number of database conferences shortly on our index engine and how it works. But that was one of the fundamental differences that we worked on. The other one that we wanted to nail was this concept of multi-doc transactions, right? Everybody loves in SQL Server or in any relational system that I can start a transaction, I can persist a number of records to different entities, different tables, different rows, and then I can commit the transaction. And if anything goes wrong halfway in between, that transaction rolls out, okay? And the database is back into a consistent state. Now, as soon as you move over into the NoSQL world and into the other document databases, many of them don't allow that behavior, okay? Some now do, but many don't do that. So you give up this notion of consistent and atomic transactions as soon as you move to one of these databases. And that causes problems, right? We've seen some horrendous looking code that developers have had to write in their applications to deal with the fact that you need compensation and undo and rollback and all sorts of crazy things, right? So we really wanted to nail the fact that we want you to be able to do multi-doc transactions. So do one operation that touches a number of different documents, and if that operation succeeds, commit all those documents. If the operation fails, roll back out and leave the database as it was. And then we really wanted to kind of, and the last two come into play together. We really wanted to make this thing tunable, okay? And we really wanted to make this thing perform. And we really wanted to kind of offer it at price points that are small increments that you can adjust up and adjust down. It's billed by the hour. All of those kinds of things that we found that taking a product that was designed to run on a server and hosting that server for you as a service didn't really give you those capabilities. So this is what we set out to do, and this is how we believe Azure DocumentDB differentiates itself from the other databases that are out there. So if we take a look, DocumentDB, very well suited to web and mobile applications, okay? But that's not saying that's the only kind of application you can build DocumentDB with, right? It'll work brilliantly in a line of business app. It'll work brilliantly in a normal enterprise kind of application. It'll work fantastically well in an IoT application. In fact, many of our very large customers are running IoT applications today on DocumentDB. We have a vehicle manufacturer that every time you start and stop your car, there's a telemetry message that gets persisted in DocumentDB. It's actually kind of scary what vehicle manufacturers collect about you, just by the way. I'm not saying which vehicle manufacturer, but not the one I drive. So one of the other things that we want to kind of do is this reliable and predictable performance, okay? When we started out, one of the very first things that we said is that we don't want to have this notion of a noisy neighbor problem, okay? Because that's the problem that puts a lot of people off from a database as a service, is that your application is usually impacted by what the neighbor on your box is doing, okay? And for us, that was an absolute non-negotiable. So we wanted to make sure that when you create your database, when you put your documents into your collection for documents, we wanted to make sure that that was completely isolated from anything else that's happening on the machine, right? So fast, predictable, tunable consistency, okay? That's what we really are going for, and we really are going for this elastic scale, okay? We think we've done well with elastic scale. We've heard from feedback during preview and the early kind of weeks of GA that there's some things that we can do better, and we will. But those are some of the kind of things that we're shooting for. And then really with Azure DocumentDB, it's this document database thing. It really is about rapid development, right? We took a couple of bets when we started out. We said, well, how do we get developers to start using DocumentDB as quickly as possible? And the easiest way was give them tools that they're familiar with, okay? So don't go invent a new query language that you have to kind of learn how to do. Don't go invent a new protocol. Don't go and invent a new kind of way to store documents, okay? There's a way that everybody loves it already. It's called JSON. Use JSON, right? There's a lot of work that's gone into, and developers love JavaScript. So let's try and use JavaScript where we can and really integrate JavaScript into the database engine. So we're hoping that it's easy to start, okay, and get up and running. And then the fact that it's fully managed is awesome, okay? I just create the database. Within a couple of minutes, off I go, and I can start writing code against it, okay? One of the things as well is that we also wanted to make sure that it's not just the service that kind of is there on its own, all right? We are part of the Azure ecosystem, and we want to make sure that when you build a web app or a logic app or an API app or a mobile app, that you can use DocumentDB. We want to make sure that when you do your machine learning kind of stuff and the cool machine learning things that you saw in the keynote, we want to make sure that DocumentDB can be part of that, right? Power BI, so when you want to run your reports and you want to do analytics and ask questions of your data, we want to make sure that DocumentDB is part of that, right? So today we already support search. So when you have a search account, you can go in and create a document, or I think they call it a data source or data connection. But you can point that at either SQL or DocumentDB, and then they will go and index or crawl through your DocumentDB and index your data for you, all right? So no more complicated writing code or double write code, put it in DocumentDB, put it in search, and trying to keep the two in sync. Now you just put it in DocumentDB, point search at it, and it'll figure it out for you. Hadoop, we've got a Hadoop connector, so if you want to do these complicated running or long-running map-reduce jobs to do aggregates and averages and counts and sums and all those sorts of things, you can fire off using our Hadoop connector. You can run those jobs and then pump the data back into DocumentDB if you want, or anywhere else. One of the cool things with our Hadoop connector is we have some customers that are into the approaching triple-digit terabyte worth of data in DocumentDB, okay? So they're storing lots and lots and lots and lots and lots of data. And when they started using the Hadoop connector, they found that the jobs would run for a really long time. And that's because we were going through 80 terabytes worth of data. Now, Hadoop's really good at doing that map-reduce thing. But we thought, well, is there a way to make that even quicker? So with a Hadoop connector, you can actually give it a DocumentDB query. The Hadoop connector will only fetch that data that you're interested in, and then kind of work through that. Rather than fetching everything, it'll only fetch what you tell it to fetch. And then work has begun integrating into all these other kind of tools and technologies. And they should land soon. So with all that, what does DocumentDB cost? So from as little as, I think it's, I don't have it on here. I do. Look, for 1 hour for a DocumentDB database is 3 cents. Okay? For a day, I think it's less than a cup of coffee, or much less than a cup of coffee. Okay, so you can get going really, really quick, really, really easy. There are a couple of things, caveats that I must mention, all right? And you'll see as we go on through the rest of the session, I hope you'll get an understanding of kind of how things work. These are priced at a collection level. Okay, so Mongo users, Raven users, right? Pay attention. These are charged at a collection level. Okay. And that's because a collection in DocumentDB is a very different concept and a very different notion to a collection in Mongo or Raven. Okay. Hindsight says we should have probably given it a different name. We shouldn't have called it a collection, okay? Because people expect to use it like they're using Mongo and Raven collections. The Mongo guys in their documentation says, think of a collection like a table, okay? And think of a document like a record, right? We don't want people to think of collections like that, okay? We want people to think of collections as a partition of data. You can stick any data into a collection, okay? Not just data of the same type, okay? And there's a number of reasons for that, because of features like being able to do multi-doc transactions, querying within collections. Eventually, we'll have some future features that are also going to kind of make more sense of why we see collections as partitions of heterogeneous documents rather than, documents of the same type. So when you start out planning for your application, don't think of a collection as a table. Don't try and put customers into one, products into one, orders into one, order details into one, because eventually you'll end up with a database that has 60 collections for like 100 mega data, and you'll be saying DocumentDB is really, really expensive. Okay. Whereas if you took all that data and you put it into one collection, it'll cost you 25 bucks a month. Okay. So, if we move on, let's take a look at the basics of DocumentDB. Okay, and this is the understanding of kind of how our resource model is put together. So you start off with a database account, you go into the portal, you create a database account. And all that gives you is this unique DNS addressable name. Like most Azure services, we fully REST compliant, we fully REST based. Okay, so everything in DocumentDB is a REST resource, and you can talk to it using a REST URI, everything. Okay. From a database to a collection to a user to a permission object to a document itself, everything is a REST object. Okay? And I can do REST gets or puts or pushes or posts to any resource in the database. Okay. So that brings me into a database. So a database is this like logical thing. There isn't a physical database. It's a logical container, a logical way to group things like collections and users and permissions together. All right. Then we get into collections. So collection is really, like I said, this container for different kinds of documents. Okay? It's a physical allocation of resources. So when you create a collection, we actually go to a node somewhere in our cluster, and we physically allocate you and ring fence an amount of CPU and an amount of memory and an amount of disk I/O and an amount of network I/O. Okay? And that's how we can make sure that we don't have a noisy neighbor problem. Okay? Because that collection has very, very specific and very hard boundaries, and it cannot operate outside of that boundary. Okay? So no matter what anyone else is doing in their collection on their node, you're getting that slice of that machine, and we make sure that you get that slice of that machine. Okay? It's a scope for queries. So today you can't do a query across collections, okay? Because a collection could span any one of our clusters. It could be 1,000 nodes. So you can't do a query that spans across 1,000 nodes. What you need to do, and we'll talk about this later, is this notion of a fan-out query. Okay, so if you're looking for data and you don't really know what collection it's in, well, then you kind of go and query every collection as a fan-out query, and then consolidate the results back together again. All right, our storage is SSD-based, so in chassis, in the machine, there's solid-state disks, and that's where your data resides. So we don't back onto Azure storage or anything like that. They're SSDs. In fact, our index engine has been optimized for modern-day SSDs, right? So we wrote an index engine that takes advantage of the hardware that we're running on. And then they're billable by the hour. So if you create a collection today and you delete the collection immediately, you'll get charged for an hour, okay? So depending on what that is, if it was an S1 collection, you'll get charged 3.4 cents. No? Yes, 3.4 cents, all right? So just keep that in mind as well when you're, especially important when you're running, let's say you're running a unit test that spins up a database, spins up a collection, does some testing, tears down the collection, okay? That's gonna charge you, that's gonna cost you 3 cents to do that today. Right. And then you get the notion of documents. Okay, now documents is mostly what you're gonna work with. That's your document, it goes into a collection, all right? No enforced schema, okay, so you can put any kind of document you like into one collection. And we are optimized for smaller documents rather than larger documents, okay? And that's because smaller documents, as you may have noticed if you've done anything on the internet or whatever, smaller documents in terms of network I/O and disk I/O work much, much better than one large document. Okay, so to save 100 small documents is actually a lot less network I/O, and it's a lot quicker because they can be parallelized operations than writing one big document. Right? So we are optimized for lots of smaller documents rather than bigger documents. And we do have a document size limit today, right? Which when we started out in preview, it was a number that we set that all our internal customers were telling us, right? We put it out there, and very quickly external customers told us that that was a very silly number, and we listened and we upped it to 128K, and then eventually we've now up to 512K for a document. Okay. Now 512K if you take JSON and you minimize the JSON down, so get rid of the nice kind of indenting and white space, because computers don't need that. Once you get rid of that, 512K of minimized JSON is actually an incredible amount of JSON, right? It really is a lot of JSON that you can fit into a document. People are still saying 512K is too little, and we're listening. We're running some internal tests on different document sizes, and as soon as we believe that we can, from a network I/O kind of point of view, handle and sustain thousands of tenants running bigger documents, we will potentially lift that limit again. Right? So a lot of these limits are in place while we're kind of testing what things can do. So these are constantly under review, and we may well lift that limit in the future. Next. And then you get other things in document database called users and permissions. So I can create a user in a database, and I can assign that user permissions. And that user permissions could be at a collection level or down to a document level. So I could say, this user can only read that document, this user can write and read that document, okay? But it's down to a document level. We don't have field or attribute level permission, it's down to the document being that. We also have stored procedures, triggers, and user-defined functions. Now, before people chase me out the room with a pitchfork, because stored procedures and server-side triggers and that kind of stuff are uncool, we think there really are value and benefits to using server-side scripts and for the right reason. Okay? Like anything, no matter how good it is, if you use it incorrectly, it's going to be horrible. But we believe that if you use it correctly, it'll actually be beneficial. For the guys sitting on the floor in the corner, unless you want to sit on the floor, there are still open chairs in the middle over here, and there's a few open chairs over there, and that kind of stuff. Right, so we also have the notion of attachments. So what you can do is you can give us a document that has a picture or a video or whatever attached to it, and we then offload that attachment to blob storage, and we manage the life cycle of that. So when you delete the document, we also go in and clean up all the attachments with it as well. When you query for a document, you can get the document back. You can also tell us to include the attachments, and we'll bring back the attachments as well. Or you can just go and store the attachments yourself, put the link to the document, the attachment in the document if you want to do it that way. Okay, so DocumentDB JSON documents, this is what they look like. They're actually, when you look at a JSON document, it's actually a tree, okay? And this is really important because this is what we base our index on, okay? Because it's a tree that we can walk and we can navigate through the tree, we're able to index every property in that document for you. So talking about our indexing, by default, we index every property, every attribute in the document, okay? We think for the majority of the users, the default's probably good, but we allow you to tweak that, and we allow you to make changes to that. If you find that you actually you know your data model really, really well, and you have a big document with 1,000 attributes, and you know you're only ever going to query on a subset of them, okay? Well, then there is a lot of fields in that document that are being wasted in the index. Okay, and that's going to cost you storage size, it's going to cost you request unit charges, that kind of stuff. So you can actually go into your index policy and you can do things like include paths, exclude paths. So by default, we include everything, but then you can go start excluding paths if you want to. Okay. We also have two different indexing modes. One's consistent, one is lazy. So default is consistent. So as you're writing the document, we're updating the index at the same time. Okay. And we find that the index keeps up under very high sustained kind of write load. So we haven't found the index kind of lagging yet. We watch it all the time, and we've got metrics to tell us whether it's lagging, but largely the index keeps up. However, if you've got these really big bulk insert kind of operations, so 8 a.m. every morning, you ingest a ton of data, okay, and it's not really that important that you can query on it immediately, then what you could do is you could set the indexing policy or the indexing mode on that collection to lazy. What that'll mean is that we just won't index while you're writing, okay? And you can ingest a ton of stuff, and then the indexer will catch up in an eventually consistent manner, okay? So you'd get higher write throughput with lazy mode. And then we also have an indexing policy that says automatic or manual, right? So you can actually switch automatic indexing off completely. So when you put a document into a collection, it doesn't get indexed unless you tell it to be indexed when you do the create statement. So you can switch automatic indexing off and then only index some documents you put in the collection. Okay, so some documents you put in the collection, you may not want to index the whole thing. Other documents you put in the collection, you want to index. So this way you can switch on and off depending on what you want to do. Okay? Now, even if the document hasn't been indexed, you can still read it. As long as you know its ID, you can still read it. All right? So you can go in and you can actually read the document by its self-link. Indexing paths, like I said, you can kind of include paths and exclude paths. We also have currently 2 different index types. We'll be adding more as we go, but we currently have 2 indexing types. One is a hash, and that's really, really good for doing equality type operations. Give me all documents where age is 20, or give me all documents where city is San Francisco. Okay? Hash indexes work really well for that kind of operation. Range index works well for give me all documents where age is greater than 30, or where date is between X and Y. Okay? So range operations, range index. All right? Now, depending on what you're doing, you can actually switch index. So as you include a path, you can see over there I'm including a path that says root, and I'm giving it an index type of hash. So I'm saying apply a hash index to everything in my document. At the bottom one, I think I'm saying ship timestamp. I want that to be a range because I'm going to do range kind of operations on ship timestamp. Okay, so that's what you can do over there. And then as you start doing these things, you can also change the index precision. And the index precision is largely a trade-off between the amount of storage that we do and the speed of the index. So the more precise you are, the quicker we will be. Okay, but the larger it may be, the less precise you are, the smaller your storage requirements will be, but the bigger the result set that we'll have to kind of scan through in the index. And then you do that. So JavaScript transactions, all right, these things on triggers and stored procs allow you to do multiple document transactions. So when you want to do that multiple document transaction, stored procedure or a trigger, okay? So what you would do is you go in, you define the stored procedure. I'll show you what one looks like, or a trigger, I'll show you what one looks like. And that can then go and perform operations against multiple documents and either commit the whole thing as a snapshot, as an ACID transaction, or if that stored procedure written in JavaScript throws an error, we roll back the whole thing and we undo everything and put the database back to a consistent state. In terms of query, there are currently, depending on currently, there are 2 ways to query DocumentDB. If you're in .NET, how many .NET developers in the room? Actually, sorry, this is a build conference. How many non.NET developers in the audience? So Node, Python, JavaScript, couple of hands. All right, cool. So I'm going to talk quickly about the .NET stuff, and then the other languages we haven't forgotten about, so we'll be making changes into the other languages soon. In .NET, you can use LINQ. Okay, so if you like writing stuff in LINQ, language integrated query, you can actually do that. And for the most part, it works. There are some operators that we don't yet support inside of LINQ, and that's because the back-end kind of query capabilities are still catching up. But LINQ works. And then for the non.NET people, or even .NET people that still prefer SQL syntax, you can write your query as a SQL query. Okay? And both work equally fine. If you're doing REST programming, you would pass the SQL as the body, and you would execute the query that way around. All right. What we can also do is we can extend queries by introducing user-defined functions. So this one over here is a user-defined function called tax. It's written in JavaScript. So you define it, you store it on the server, and then when you execute that, you can actually then include the UDF in your query. All right? And you can do some really cool, powerful things with UDFs. If you're writing in LINQ, this shows how to include the UDF in SQL. If you're writing in .NET LINQ, you can invoke the UDF from LINQ as well. So you don't have to fall back to SQL as soon as you use UDF. You can use a UDF in a where clause. Right? So I could have said select name from company, from root, where type equals company, and tax greater than 0.2. Okay? I can do that. Be warned, though, that as soon as you put a UDF into the where clause, if that's the only predicate in the where clause, we then can't take advantage of the index, right? Because we can't parse the index through your UDF, right? So we then would resort back to a scan and scan all the documents and pass them through your UDF. And that's why I say have at least one other filter in your query if you're going to use a UDF in the where clause. So in this case, it was like where type is company, but I could have said where headquarters equals Russia, and then put the UDF into that. And that means we will first go to the index, find all documents that match from the index, and then we'll parse that smaller subset of documents into the UDF, right? Rather than every single document that's going to go through the UDF. All right. So the kinds of applications that we're seeing people build are your traditional web app, right? So ASP.NET, Node.js on the back end. We also support other things on the back end. We have full support for Java. So if you want to run a Java web application, we have full support for Java. If you want to run Python, we have full support for Python, that kind of stuff. So ASP.NET and Node.js on Azure websites, for instance. We also have PHP, Ruby. Okay, some guys out in the community have started a PHP and a Ruby driver for us. There's also now, I see, a Go driver. So community effort is picking up really nicely. So go have a look on GitHub for those. And if you want to contribute to those, please do. The Node.js, the Java SDK, the JavaScript SDK, those are all open source. If you want to contribute back to the SDKs, feel free. The .NET one is not open sourced yet. There are some internal compliance issues that we're working through to get that one published. But rest assured, we will publish it. It's just a little bit more work to publish that one. But we will get there. All right. So we can also support, so this model here was your traditional kind of three-tier web application. You've got the web client, you've got a web server, and you've got a database, right? And how that web server or that web tier talks to the database is using this notion of a master key. Okay? That master key, who's used Azure Storage? Okay, a couple people. Azure Storage gives you a master key, same as we give you a master key. Now, with that master key, you can do absolutely anything on that database account. You can drop a database, you can create a collection, you can do whatever. Okay? So you need to keep those keys secure and safe. So when you're doing a middle tier kind of application like this, and that application's running in Azure, you can keep the key in the middle tier and be fairly confident that no one's going to get hold of that key, right? We also want to cater for the single page kind of web application, the two-tier one, where you have no middle tier, okay? And the web client is talking straight to the database, right? Now, what you don't want to do here is you don't want to put the key into your web application, okay? I'm going to ask the question, but hopefully it's obvious. Why don't you want to put the key into your web application? Thank you. All right. That's because that key is then sitting on every device that is accessing that thing, and you've now given away your SA account and SA password to your database. It's not a good idea. So today, we still require that you have a small middle tier that the client will go and connect to and says, hey, this is who I am. We will then go off to DocumentDB, and we generate effectively a SAS token, a shared access signature, for that user for a period of time. Okay? And we then return that SAS token to the browser, and that's what the browser uses to talk to the database. Okay? It doesn't use the master key. It uses that short time-lived shared access signature. Okay? And eventually, that shared access signature will time out. You can set how long the duration is. And when it times out, it has to go back to the middle tier, get a new token, and then connect back to the database. So that's how it works today. We don't yet have integration into things like Azure Active Directory, so you can't go to Active Directory, sign in, get a token, and pass that to DocumentDB. It's something that we're investigating, but it's not there yet. We also fully support mobile applications, and like your single-page apps, please don't put the key in your phone app, or in your iPhone app, or in your Android app. Okay? Again, people get a hold of that app, they decompile it, and there's your key. Okay, so please don't do that. Either do something similar to what I had before, or use something like Azure Mobile Apps. Okay, Azure Mobile Apps then has the key and the way to talk to the database, and all the application does is authenticate against that, and then mobile services or Azure Mobile Applications proxies the call to the database. And then using Azure mobile apps, you can either write a .NET backend or a Node.js backend. And then that's how that works. IoT applications, we see lots and lots and lots of kind of IoT use, especially when we hand out things like Ruby Pis and NetDuinos. We see lots more people kind of writing these kind of applications, and they're awesome. What we've seen a lot of is when we started out with this, some people would say, well, okay, I'm going to try and kind of get my device to talk straight to the database. Again, a problem because the device needs a key. Okay, so don't do that. Right? What you want to do is have your devices speak to something that's cheaper and easier and even more scalable. Okay, something like Azure Event Hubs. Okay, so you get the device to talk to Azure Event Hubs, dump all the messages in bulk in there, and then you have some kind of a processor to pull it out of Event Hubs and stick it into DocumentDB. Now that processor can be something that you custom build and run on a worker role. It can be something like I've shown here, which is Apache Storm or Azure Stream Analytics. Okay? They can connect to Event Hubs for you, pull the data out, do real-time analytics on them if you want, okay? Do something with that, and then push the results and the raw data files into Azure DocumentDB. What you can then do over time, especially these IoT applications that generate terabytes of data a month, by the end of the year, you see your bill has got to an eye-watering, really large number. So what you want to start doing is you want to start aging out old data. So you will then have a process that will go and find data that's old in DocumentDB, and we'll talk about strategies to do that in a sec. But what you'll then do is you'll have that process age out the old data into something like the Azure Data Lake, which was talked about on day one, or was it yesterday? I can't remember. But there's now an Azure Data Lake which you can dump data into, and then you can run your analytics jobs on top of the data lake. So some things to kind of look at when designing a DocumentDB application. Right? So yes, there's still some design, even though we're this agile, kind of flexible, this cool world, there's still some design that we have to kind of do up front. We generally say, start off by modeling your data. Okay? And don't worry if you don't get it quite right. It's easy to kind of remodel your data. But start off with some kind of an idea. Think about what are these entities that you're going to work with? How are you going to work with them? Okay? How are they going to be queried together? How's your web application or your mobile application going to query for them, use them, write them, that kind of stuff. So think about your access patterns. Then what we say is kind of come up with your top 5 to 10 queries. Okay? Now use the real data that you've modeled as JSON and use them in those queries. And then what you will do is every time you execute any operation against DocumentDB, you get back a request unit charge. And that request unit charge is the currency that or the charge that we applied to that operation. So you'll see, like if I do a read, I get back an RU charge of 1. If I do a write of a large document, I might get back an RU count of 100. Okay? Model your data, your queries, measure what your RU charges are, because that'll help you plan your capacity. That'll help you understand whether you need an S1, an S2, or an S3, or if you need 1,000 S3s or 100 S1s, or whatever the case may be. It's the only way you will know. Okay? But then measure those RUs constantly. Okay? We'll have metrics in the portal that'll tell you what your average RU count was. What was your maximum RU count? What was your minimum RU? That kind of stuff. So measure that, keep track of that. And as you see, if it's starting to get too high, you may want to go back and look at remodeling your data or changing your index or optimizing your queries and those kinds of things. Okay, so data modeling with denormalization. So the biggest challenge that people coming from a relational world into a document world is, how do I model my data? Okay, because it's very different from how I model my data in a relational world. Let's say I have an application that's dealing with motor vehicles. Okay? In a relational database, what I would probably do is take that motor vehicle and break it down into its 1,000 individual parts. And then I'd probably store those individual parts all over the place. And when I wanted to work with a vehicle, I would write a query that would join all of the tables together and reassemble my vehicle. Okay? In a document database, most of the time what we're doing is saying, don't break the vehicle down. Okay? Store it as it is, as an entity. Okay? Now, these are some things that denormalization is kind of good for. So when you're doing one-to-few relationships, Okay, so here I've got a person that has a few contact details. Okay, the embedded data changes infrequently. And what I mean by that is if I was linking to, I don't know, let's say the address, right, in this case, and the city was Washington, and it has a zip code, right? Now, if that zip code changes often, okay, then you potentially don't want to do that, because what you would do is you'd have to go to every single document that has Washington and go and change its zip code, right? Whereas in a relational database, it would be a whole lot easier, because you'd go to one record and change that in one place, and then everybody would know about the change, okay? This time, think about how many times that value that you're denormalizing is being reused, okay? And largely, denormalizing provides for better read performance, okay? So in applications, you typically, unless you're doing a little bit more complicated architectures, you typically compromise either read performance or write performance, okay? So you can either model your data for really, really good read performance, or you model your data for really, really good write performance, or some kind of compromise in between, unless you're doing something like CQRS, where you have two different models representing your data. But typically, a denormalized model is better for read. Why? Because when I'm reading an entity, I go and I get one entity and I bring it back. I don't have to go to 15 tables, reassemble it, and then bring it back to me, okay? Sometimes, though, denormalizing is not the right way to go, and you can still, in a document database, do referencing. The referencing here is weak links, though, okay? Because the server doesn't enforce those links. So here I've said, when I insert an address document with user ID XYZ, the database won't go and say, hey, there's no user called XYZ, therefore you can't do this, okay? It won't do that for you. It'll just gladly accept it. So you could end up with broken links. You can use a trigger in DocumentDB to kind of go and enforce that if you want. So you can create a pre-trigger that says, when I put in an address document, make sure there's a user that matches this user ID. If it isn't, reject the address document. Okay, so you could do that in a trigger. Data modeling with referencing is usually better when the reference data changes frequently. So when you want to go in and update that piece of reference data that's being referenced by lots of other documents, think about referencing your data. Now, data modeling with referencing, when you have a heavy write workload, it's often kind of, you'll get better performance out of your write workload. All right. You can also aggregate these things. So you can have hybrid models where some of your data is normalized, some of your data is denormalized, okay? So some tips, I'm just going to flick through these slides quite quickly because I want to get to the next part and I'm running out of time. But some tips on JSON data modeling. Okay, the slides will be available afterwards so you can go and have a look at those. But some of those things over there, they may seem small, but they make a very, very big difference when you model your application. Okay, indexing policies. Again, I told you can play around with indexing policies and ranges and precisions and all of that kind of stuff. So do your queries, look what your RU charge is, modify your index policy, do the same query again, see what your RU charge is. Okay. Querying, there are things that you can do with querying to optimize, all right? So go for smaller result sets, limit the use of scan operations. Okay, so if you don't have a range index on a field, don't do a range operation, okay? Don't write queries that say not. Okay, so often people will say, select star from database where gender is not male. Okay, don't do that, okay, because that results in a scan. Rather do a select star from database where gender equals female if you're looking for all the ladies. Okay, that's a much more efficient query that'll give you the exact same result set than saying we're not male. Okay, so simple things like that. If you have UDFs in where clauses, include other predicates. All right, so partitioning. In DocumentDB, you need to partition for two reasons. Data size, because every collection is only 10 gig in size today, and throughput. The maximum collection that you can have is 2,500 request units per second. If you need more than that to serve 10 million concurrent users, okay, which we have a customer that does, you need to scale out across multiple partitions. How do you scale out? So there's a couple of different ways. The first is spillover. So you start with one partition, you fill it up till you get to some kind of headroom, and then you start spilling over to the next one. Okay? You also have this notion of a range. So start off with the current period of time, okay? Today, 7 days, this month, this year. And then when that period falls over, you move to the next one. When that period falls over, you move to the next one. And eventually, you'll then age out and purge out old data. Okay? And then you also have this notion of a lookup. So some kind of lookup. So I'm partitioning by tenant, or I'm partitioning by region, or I'm partitioning by vehicle VIN number, or whatever the case may be. I have some kind of a shard map that I actually look at. Let me skip this one because I want to show you what we've just recently announced. So if you go to partition hash, hash says, I've got 100 collections. I'm going to evenly distribute them, all data across those collections. I'm going to use some kind of algorithm, and that will then go and spread your data across those collections for you. Okay, we'll skip that one. So if you take a look at fan-out queries, this is what I was talking about earlier. Sometimes data may actually exist in multiple containers, and you need to do a fan-out operation. Now, languages like .NET allow you to do parallel query execution. So I can fire off those 3 queries in parallel in one operation, and asynchronously sit and wait for the results from each of those to come back to me, aggregate the results, and present that to my application. Okay. Yes, it's multiple calls to the database, but when your web application is sitting in the same data center as an Azure document database, it's multiple calls over sub-millisecond kind of network infrastructure. It's really not that much of a big deal. All right, so when you want to design for partitioning, those are the 3 that I've kind of looked up, and they've each got some pros and cons. Right? And unfortunately, there's no one kind of solution that fits everybody's scenario. These are largely the 3 patterns that we're seeing customers doing today. So lookups, ranging, and hashing. Okay? So partitioning sounds hard. Okay? And lots of users have come to us and said, partitioning is hard. I have to write a lot of extra code. Please help. Okay? So just yesterday, we announced that we have included partition resolvers in the new .NET SDK. So what you would do is your app talks to the app tier. The app tier figures out what kind of partition resolver it's using, so either hash or range or lookup or spillover or any of those. And it then talks to the .NET or passes that partition resolver to the .NET SDK, and the SDK figures out which collection you should be in, and it goes off to that collection. Okay? So your many collections, and we have some customers that have 1,000 collections, they now appear as one logical database. Okay? So if anyone's worked with DocumentDB before, when you write a document, you tell us which collection to go put it in. Now you don't. You tell us which database to put it in, and you tell us what partition resolver you're using, and we go figure out what collection to put it in or get it from. Okay? So, thank you. There's still a little bit of work that you have to do, though. So we haven't done it all for you. There's still some work around managing those partitions. So when your partitions get too big, or you want to add in extra ones, and you want to shuffle data around and that kind of stuff, there's still work that you have to go do there. We're still looking at what we can do to make that easier for you, but that's that. I will post all the demos online. In fact, they already are, so I'll jump to actually where, in a second, where they are. They're there. So if you want to go to DocumentDB partitioning, all the samples and the demos that I was going to run are in that folder. Okay? So they will show you how to go and use the built-in hash partition resolver, the built-in range partition resolver, the built-in spillover partition resolver. Okay? And then we expose an interface called iPartition Resolver that you can go and write your own one. Okay? I've written one for a customer already that was a combination of hash, range, and spillover. Okay? So they have, well, it's actually range, hash, and spillover. So they have a range of things. Within that, they have a hash because they have a number of collections in that range. And then as those collections fill up, it spills over to another one. Okay? So using iPartition Resolver, there's basically 2 methods. One that says resolve for read, one that says resolve for create, and you go and implement the code that figures out how to do this. And you can go write your own ones, and in that, at that URL, there's about another 4 different ones that we've actually built. And what we're hoping is that we kind of build up a community of people kind of contributing their partition resolvers. So if you build a cool partition resolver and you want to share it, please go put it into that GitHub repository and share it with other people. And what it'll mean is as we see more and more of those people, we may then kind of look to bring it back into the core SDK or that kind of stuff. Okay, so roadmap time. I promised you roadmap. I have 30 seconds, so let me go through roadmap quickly. So we were public preview in late last year. We GA'd a couple of weeks ago. And since then, we have done deployments every single week, okay? Every single week, we've pushed a deployment. We've pushed hundreds of deployments, sometimes even more than once a week. And what we've been actually focusing on is making sure that, first and foremost, the service is stable, it's robust, it's reliable, it scales, okay? So yes, there are a couple of features that we're short, all right? But we needed to make sure that the base was solid that we can build these features on top of. So we're still kind of catching up a little bit, and there's still some foundation work that we're doing, and we have a whole bunch of features kind of queued up. And as soon as we feel comfortable, those features should roll really quickly. So short-term future in the next, I don't want to commit too much, in the next weeks, we should be able to see name-based routing, okay? So people have told us they don't like self-links, okay? Self-links, when you look, they use internal URIs. So every resource has a URI to it, okay? When you create a document, we create this internal thing called a resource ID, okay, which is unreadable and it's you don't know what it is. So you know your document by its ID. You don't necessarily know what its resource ID is. So in order to go and read that document, what you got to go do is you got to go query for it, bring it back, get it self-link, and then use it. Okay, so self-links are a pain. So what we're bringing out fairly shortly is this concept of name-based routing. Name-based being the ID that you've given us. So if you've created a document called My Document ID, you'll be able to include that inside your URL. Okay, so your URL will now have your supplied IDs in it instead of just our internal resource IDs, which will make, we hope, a huge difference. So we'll also be doing range indexes for strings, so you can do things like starts with, ends with, contains. And then probably the big one that everybody's waiting for is order by. So yes, order by is queued. It's in our internal test environment. It is going through some serious kind of stringent testing. And as soon as we feel comfortable, these three features will land. And they'll land hopefully fairly soon. I'm hoping to have it, no, not that soon. And we're only just getting going. We have features planned for ages, okay? We're only getting going, and because this is a service, it means that we can deliver features on a weekly basis if we need to, on a daily basis if we have to, okay? So please keep telling us what the features are. Please don't think we're ignoring you. We're not ignoring you. We're listening to every single feedback request that comes in, okay? And we feed them into our planning, and we feed them into our prioritizing, and every single kind of piece of feedback that you guys give us goes into planning the future of the service. So please keep giving us that. And that was a shameless punt because we are looking to grow our team. So there's the feedback in the forums. So the user voice one and the forums if you've got a problem. So user voice, if you want a feature, go vote for it. Forums, if you have a problem, go post it. I personally spend way too much time answering forums and not responding to other things that I should be doing. But that's because I feel passionately about helping people kind of get over any problems that you've got and using those problems to learn how we can make the service better in the future. Okay, so it's a great learning experience for us. Then the product page and the docs and tutorials page, if you're looking for more info and more docs and tutorials, we keep publishing new docs, new tutorials all the time. So please go and have a look there. And use the feedback. If you like the document, tell us you like the document, because that gives us an idea of what kind of documents you like. If you don't like the documents, tell us you don't like it and tell us why you didn't like it, because then we can go and improve that document, right? Then samples, there's lots and lots and lots and lots and lots of samples that we push out all the time. So have a look at that one. Then blog and Twitter. If you want to follow us on the blog and on Twitter, that's where we announce kind of cool new things. So if you were following us on Twitter yesterday, you would have seen the announcement of the partitioning and sharding support already. So I know we're a little bit over, so we probably won't spend too much time on the stage doing questions because I've run out of time. So sorry about that for the people watching at home. But if you have a question, please come find me. I will be outside the session room, so come find me, and I'll happily answer any question that you have.